Okay, so fourth video for section 10.7 polar coordinates. In video 3 we looked at the formulas that we would use to convert coordinates from rectangular to polar or from polar to rectangular. So let's just write down our conversions here. So um, polar to coordinate, polar to rectangular. We had x is equal to r cosine theta, and we had y is equal to r sine theta. And then rectangular to polar, we had theta equals tan inverse of y over x, and we had that r squared was equal to x squared plus y squared. Alright, so we've got those handy. We can refer back to them. Alright, so for our example here, the directions are simply to convert each. So you got to figure out what you're starting with, and then you can convert appropriately. So for example part A, I'm going to start with 2 pi. So we can see, since we have pi in here, that this is a polar coordinate and we want to convert it to rectangular. So we're going to use these formulas up here. So we know that x is going to be r cosine theta, which is 2 cosine pi, which is 2 times the cosine at pi is the x coordinate pi is -1. So that's going to be -2. And the y coordinate is going to be r sine theta. So that's going to be 2 times the sine of pi, which is equal to 2 times the sine is the y coordinate. So the y coordinate at pi is 0, which is going to be 0. So the x, y coordinates of this point are going to be -2, comma 0. So let's take a quick look at what this would look like. If we draw a little sketch, if I wanted to locate 2 comma pi, I would draw a circle that has a radius of 2. So you could draw 2 circles if you want. I'm going to draw one, make sure I label the circle that has a radius of 2. So I'm going to go out to 2 and then rotate around pi to end up right over there. So we can see that if we just made this xy, we would simply go to the left -2 and up or down 0, and we would be at that spot. Alright, so that's converting from polar to rectangular. Let's take a look at another example. Part B. Let's take the point 3 root 3. Okay, so again, there's no angle in here, so we can see, let's block this off a little bit, that if we graph this, I would go out 1, 2, 3, and then I would go up square root of 3, which is about 1.7. So it would come up somewhere about here, and that's where the point was. So we want to figure out, if I was going to graph this in polar, where it would be. So I know that r squared is going to be x squared plus y squared. So that's going to be 3 squared plus the square root of 3 squared. So that would be 9 plus 3, which is 12. So that means that r would be the square root of 12. And if we simplify that, that would be 2 root 3. If you have questions about that, make sure you ask me in class. And then we need to find theta. Theta is going to be the tan inverse of y over x. So that's going to be the tan inverse of root 3 over 3. And if you think back to the unit circle days, we want to find an angle. We can see that it's in the first quadrant over here. So we want to find an angle that has a tangent of root 3 over 3. And if you recall, that's going to be pi over 6. So if we take all this and put it together, we end up with r comma theta is equal to 2 root 3 pi over 6. And there you have your answer. Okay, so feel free to watch this video again. Make sure you write down any questions and ask them next time you see me in class.